How are you guys? Welcome back to my YouTube channel. This is fluid mechanics. You're still under fluid mechanics N6. The flow of water in open channels. Please do not forget to subscribe to this YouTube channel. Please subscribe. Just subscribe there so that you'll be notified whenever I post a new video. Stay alert. Subscribe. Click that button there. Just subscribe. Before you start watching, just subscribe, please. Okay, let us check here. I've underlined there. You see what I've underlined? Of the sides of smooth stones. That is what is important. The question says, a trapezoidal channel with sides of smooth. Note that is smooth. I've spoken about the smooth. We don't use that previous formulas that I've shown you. Do you remember when we are dealing with 45 degrees, 60 degrees, all of that things? You remember here we have what side of smooth. There are special formulas we apply and there are special methods that we use on this type of equation. I say take the notes that always when they say sides are smooth, or whenever you say we read a question, it tells you about trapezoidal channel with something which is smooth, you apply this method when it is smooth. Those one, they will never tell you about the smoothness, right? Good. So the formulas you're supposed to know. Okay, the structure, you can write it if you feel well. You know this structure, it says trapezoidal sides stone is 1.9 width wide at the base. That means you've given a base here. The base, this base here is what? Is 1,2 m. This is a base, will be like this, isn't it? The shape of this thing is like this, right? It's a trapezoidal. Always must be like that, must be like that. Then these are the sides of the channel. They said the ratio of the sides. These are the sides. This, it's a base. This one, it's a top width. This one is the top width. You must know that it's a top width. Whenever the sides are smooth or the base or what, the smoothness, you apply these formulas. These are special formulas for this one. This is different from that one, from the previous ones. You understand? Top width, that is the side there. Always draw this string. As you draw, even if just do like this, always draw. You know, this side, this base. Start by drawing. Whenever you encounter such a question talking about trapezoidal with smooth stone, trapezoidal side with smooth stone, trapezoidal side. When this is smooth, draw the structure exactly here at the base. From here to corner, do like this. Do the identity text line like this. Construct identity text straight up like this. Yeah. Do and extend them like this. Extend the head entities like this, and then call this distance x. This distance from here up until there, call it x. It's up to you which letter you want to prefer, but call it x. Start by doing this always. Then the distance from there, from here at the corners, at the top here until there, call it top width. Top width. Right, always this one must be a base. This distance from here, base, which is b. This distance is b, and then we're given it. They said the base is 1,92 m. This is b. Always know the structure. And then at the side, always here on the side, always draw a little triangle like this. Always when you're given this, draw a little triangle like this. Construct a little triangle like this here. can construct a little triangle and then call it theta here, and also call it here theta, right? Then you'll read from then you'll take the ratio here from the question. In the question you say the ratio of the channel sides. Remember, these are sides, right? The ratio of the channel sides. The ratio of the channel sides, they say, is 1 vertical. Here it's a vertical 1. Vertical here, it's what? It's 1. Vertical is when you're going up. They say it is 1. And then 2.5 horizontal. Horizontal is 2.5, right? Up, then here it is, it's 1 here. Here is 2.5, right? Here it is 2.5. It's 1 is 2.5. You understand those? Understand that? Now, after this, what is important, take this structure. I want us to use this structure. The structure that we'll use is this one. Abstract this path that I've shown with the hidden details. Take it out. Take that is the one that we'll use there. You understand? Write it like this. When you take this out, you're supposed to get something like this. I just want to enlarge it. Right, this theta and this theta here. Here is what is x. Here, because this distance is the same with this distance, which is depth. Here will be what? D. From here until there is D. It's a depth. Here it's a vertical, which is 1. They've given us these are ratios. It's 2.5 here. 2.5. So what is important is this structure. If you can understand this structure, you're good to go. That structure, just do that triangle, that side x, you understand? D, y is the ratio that you take them from the question, the ratio sides. Just do this, you are done. Sorry about this, sorry about that, sorry about that. Sorry about that. So I'm still in saying you just do. Let me adjust the camera a bit. Right, you do this, you know, this structure. This structure, you'll use it for step 1. Right, step 1, we focus on this. This you call this triangle 1, triangle 2. You understand? Triangle 1 and triangle 2. Let's focus here. We answer with step 1. Start here. Step 1. Let's focus on this diagram. Let's go. Triangle 1. We start by triangle 1. We follow the alphabet. Triangle 2. We come to triangle 2. Right. Triangle 1. You come. Every time step 1. You write tan when you're given this question. Tan theta is equal to, you know, tan theta is what is opposite over adjacent. Right, opposite over adjacent. You start writing. First step is you will say theta is equal to opposite over adjacent. Good. Opposite over adjacent. This part is for the small triangle, and like it's for triangle 1. It's for the ratio triangle. Ratio sides. radial sides, triangle, radial side triangle. Then the tan theta here is for the second triangle, which is triangle 2. You will use triangle 2, second triangle, which is the one, the bigger one, the one which include the second triangle. What I'm meaning is for the, follow, if you follow that exactly as I'm telling you, step 1. If step 1, you follow what I'm saying right now, there's no way that you cannot. Let me adjust here a bit. Sorry about this. Right. For this is for a triangle 2. This one, triangle 2. Use the information for triangle 2. Use the information for triangle 1. Here it's our structure. Do we have triangle 1? Yes, this is triangle 1. You come here, we follow that information. Opposite of adjacent from triangle 1 is what? Opposite is this, is 1, right? It's 1 over, opposite is what? Is 2.5, right? Here, remember, tan also is what? Is opposite over adjacent. Tan theta is what? Is opposite over what? Over adjacent also, right? Since it's opposite over adjacent also, what about triangle 2? We take the information here of the triangle 2. Tan is opposite over is also here opposite over adjacent, right? Tan itself is equal to this, whereby then we know, but we take the information from what? From triangle 2. Here's triangle 2. Here opposite is this side, is D. You write here D over adjacent, again it's X, it's adjacent. You see what we get, what we got. Formation for triangle 2, information for triangle 1, but we know tan is opposite over adjacent, that one, you understand? Then you come, D, it's a depth. Do we have a depth on your question? You write the statement, if the depth of the water flows is, they give you the depth, you replace that, it's 1,35 over x is equal to 1 over 2.5, right? You see, 1.2.5. Then you apply your maths, mathematical, you apply your maths here. Then you know this side, okay, it's 1,35 over x. This is the same as 0, when you punch that 0,4, makes x the subject of the formula. You take it, you make x the subject of the formula. Then you'll find you should get that x is equal to 3.375 meter. What is x? Is this x here? You have x. Right. That was step 1. Still under step 1. Then you have to find the top width. The second step we say is top width. Top width. Top width. Your top width must be right like this, will be 2x plus b, always 2x plus b, always from the smooth stone trapezoid. From this, when you see sides of the smooth stone, your top width will be 2x plus b. Always we have x, here is x, substitute that x, 3.375. you sum up with that b. What is b? Do we have b? Yes, it's a base. They've talked about b, it's a base, represent a smooth width 1.1,92 width at the what base. We have a base which is 1,92, right? punch on your calculator. This is supposed to get, this is 8 comma something, 8,67 meter. That is step 1. This is the necessary step you have to know. You understand? Those are necessary steps you have to know. Right. Now we are done. Step 2. We found an area. An area of the trapezoid is 1/2 into depth plus base. No, I'm making a mistake about it. It's not the depth. It's 1/2 into base plus width. A top width plus top width multiplied by the depth. So you can just write this. You can just say B plus width multiplied by depth. This is the formula you need to know for step 2. This is an area formula for trapezoid. You must know this formula, right? 1/2 into bracket base plus width multiplied by depth, right? Then you substitute what you know. Your area is 1/2. What is base is 1,992. What at the top width we calculated here is 8,67. What about the depth? Multiply this about the depth is 1,135. 1,35. Then you punch this on your calculator. Then you're supposed to get that area. Must be 7,149 meter squared. It's measured in meter squared. That is in area. Right. Let me erase here. That was step 2. Right. That it was step 2. Isn't it? Now let's check step 3. Step 3 is perimeter. After area, calculate the perimeter. Weighted perimeter, we know that is area. Calculate weighted perimeter. Not the is not the mean depth. Weighted perimeter, we know of the trapezoid. I've been talking about this thing, you know. If you watched the weighted perimeter, I've been talking a lot about the weighted perimeter. You know the weighted perimeter will be B plus 2D. I've been told weighted perimeter of a trapezoid. Use this formula. What is the base? Base here 1,92 plus 2D. Depth 1,35. Perimeter. What is our weighted perimeter? It must be, we want weighted perimeter. No. Wait. No, the formula is right, but the substitution is right. The formula is right. But what about the substitution? Remember, the structure is like this. We want we have that triangle, right, which you could apply what is this, a Pythagoras theorem, right? Must apply Pythagoras theorem to get what we need. Must apply the Pythagoras theorem. Must apply the Pythagoras theorem from the biggest triangle, from triangle 2. That triangle 2 was like this. Here what's x, right, which you got its value. X is what is 3.375, and then here we have in theta. What about depth? The depth here to our d was 1,35, the distance from here until there. Then we want this side, the hypotenuse side. Then we apply the Pythagoras theorem. Pythagoras theorem states that x squared plus y squared is equal to r squared. As we want the r squared, here we have x, we have 3, substitute x is 3.375 whole squared plus 1,35 squared r squared. Then we take the square root of that. Then we will take the square root. Take the square root. Take the square root. This will cancel. Then our depth. This r will represent the depth. Represent the depth. Represent the depth. Here actually supposed to be our hypotenuse when we apply. Let me just say x, then our x is this, x equal to the square root of all of these things that is on side there. What is that square root? Square root of 3,375 squared plus 1,35 squared, right? Right. Find this on your calculator. Square root of 3,375 squared plus square root of 1,35 squared. This will give you x. Find this on your calculator. You get 3 is equal to 6,345 meter, right? That is your x here, which is this x is the same as the depth. This is depth. This distance from here will also be equal, from this question will also be equal. This will be this depth here, or x can replace it with the depth. Then we substitute this here, x1. In other words, for the sake of not confusing, we can use right. Let me change this formula here, make it x, and here x, and let it be x, let it be x, to avoid confusion. Let it be x. Our x is 3.6 3, 5. For sake of avoiding confusion, a pyramid, let it be 2 plus 2x. Then you'll find your x using your Pythagoras. What is a base? With base is 1,92 plus 2. Our x is this one. We replace that x here. Is 3,635. Right. Then hence the calculator 1 plus 9,2 plus 2 times 3,635 into this will give you 9,19. Right. 9,19 meet. That is our pyramid. Here replace it with x. Use this formula. P is equal to base plus 2x. X use the Pythagoras from the big triangle 2. From that stuff you remember we had a triangle 1, but now we're focusing on triangle 2. You understand? Fine, we have now you had that. Now since you had that, let us erase here. Let us check what step 4. Step 4 must be M, right, which is area over width pyramid. We calculated area, you remember, and then we got area that was 7,149, right? Width pyramid has this one, right? 9,19. Punch your calculator, supposed to get 0,778 meter. This is our M, right? Why it's meter? Here is meter squared, here is meter. You cancel one, you left with meter. When you apply your math there, then let's do gradient. Let's check the gradient. How can we find the gradient? Because we are given the slope is a gradient, so we can calculate the slope. You know that is h over L. What h, you take this, is measured in meter, which is 1,92 over, there's a kilometer here. Remember we are given that the slope is equal to, we're given that the slope is equal to 1,92 meter over kilometer. How can we rewrite this? This is the same as you write this on the top as it is, but over, we just only convert this. We know that represent what, 1,000, right? Just like this. Then because it's in meter, meters and meters will cancel. It's in meter, meters and meters will cancel. We'll be left with, that is our 9,2 into 1,000. That is our I, man. Let me punch on your calculator. When you punch this on your calculator, you're supposed to get that I is 1,92 times 10 to the minus 3. When you write, use the shift factor, and that is I, right? It's a gradient or a slope, right? Since we have K in our formula, if we have K, we're supposed to use benzene formula. We have given K, remember benzene formula. We're done with that. Step 5, since we're given K, we must ask ourselves, why did they give us K? K, we apply the K using benzene formula. Benzene formula. state that basic formula state that C is equal to what? 87 over 1 plus K over square root M. That's the basic formula, right? You substitute what you know. Here it's 87, here it's 1 plus our K is 0.6, 0.16 square root M, where it's M is this one there, 0.778. Then you punch that in your calculator. You're supposed to get that C is 73.64 meter. Is measured, remember this is measured in meters half per second. Per S. This you have per S. That is C. What done with the C? What they want here? The flow quantity, which means the flow quantity is Q. The 1Q here, which is the flow, it's a rate of flow. It's a flow rate, the 1Q, the rate of flow, right? It's what they really want. So since they want that, let me erase here. We know that Q is equal, since we have this C, our formula that we use must be area multiply. We must use this C. You cannot calculate just this C. You must use this formula that has C, our velocity. Remember, Q is equal to A multiplied by velocity, but the velocity we use this one because we have calculated the velocity. You cannot just calculate the velocity for fun, right? So it's area. We did calculate the area. Even here is an area. You can take that area as it is there, 1,49. C, we have calculated it here, 73.64 multiplied by the square root of M. We've calculated M. Here it's M, 0.778 multiplied by I. We did calculate it. It's here, 1.92 times 10 to the minus 3. Punch your calculator there. You're supposed to get 20.35 cubic meters per second. Remember the method in cubic meters per second. If you want it in liter, remember you can want it in liter. Remember again, you must remember 1 liter is equal to 1 cubic meter. You want 1 liter is this. You use the proportion. If you want this in liters, you can come. What do you have this in? If you want this in meter, you know, use a proportion. You will use the proportion. What 1000 liters is equal to what? 1 cubic meter. Right, 1000 liters. It's 1 cubic meter. Now we are done here. This is what we needed. I hope you found this helpful. Those are the steps you're supposed to take if you're dealing with the one that has a smooth surface, smooth sides. If you're given smooth sides, these are the steps you're supposed to take. You're supposed to pass through those stages, right? All the best. Thank you guys for watching. Please subscribe to my YouTube channel. Do not forget, please, and share this to your colleague.